So we're given two sides and an angle for a triangle and asked to see how many triangles we can make and then to solve any that results. So we always start by drawing our triangle. We have a 10-degree angle, which is not very big. So we can make it look correct. So here's 10 degrees for angle B. And side A, which is the adjacent side, is 17, followed by the opposite side, which is 12. So we know that B is opposite because it has the same letter of the angle. And sides are always opposite their letters. So the question is, how many triangles can be made? So the first thing we do is we calculate the height of this triangle, because that's really the thing we need to analyze. You always calculate the height by taking the adjacent side and multiplying it by the sine of the given angle. So since 17 is the adjacent side and 10 is the degree, we plug this into our calculator and get 2.95 is the height. So we notice that the height is the smallest side, followed by the opposite, followed by the adjacent. And if this is the way that your ratios work, that means we're going to have two triangles that can be made out of this given information. Okay, one of them will be exactly the way that it looks here, and the other one will be, well, we'll talk about that in a minute. So let's go ahead and solve this triangle then, because that's what we're asked to do. We need to figure out the measure of this angle, which will be angle A, and the measure of this angle, which is angle C, and little side C down here. And we do that by using the law of sines. So if we take 12 and divide it by the sine of 10 degrees, that's the same as 17 over the sine of angle A. So we cross multiply. So 12 times the sine of angle A equals 2.95. Okay, divide both sides by 12. The sine of A is equal to 0.246. And now we get rid of the sine by taking the inverse sine of both sides. And we find out that angle A has a measure of 14.2 degrees. So back to our triangle. A is 14.2. Triangle, where are you? Here you are. 14.2. And we find angle C by subtracting those other two from 180. So 180 minus 10 minus 14.2 gives me an angle for C of 155.8 degrees. So back to our law of sines, we have 12 over the sine of 10 is equal to little side C divided by the sine of 155.8. So when I cross multiply here and divide there, I get a side of 28.33 units long, okay, for the side of that triangle there. So we said there were two triangles, so we have to do this sort of all over again. So if one of the triangles looks like that, where this is your base and this is 17 and this is 12, then the other triangle is formed by rotating this 12 side around to here. Okay, where this angle B here, that was 14.2 degrees, is replicated over here on this isosceles triangle. So we now have, this is angle A, and this is angle B, and we still have angle C up here. So this is still 12 units long. So angle B is now a supplementary angle to 14.2, So if we do 180 minus 14.2, we get angle B is now 165.8 degrees. Okay, there's no need to use the law of sines again. It would just give us 14.2. So we need to know to subtract this one from 180 in order to get our angle. And then angle C is still that one minus 180, just like it was before. So we subtract the other two from 180. And the second angle C is a measly 4.2 degrees. Okay, pretty minute. So I still have to find side C, and we go back to, once again, the law of sines. So little side C over the sine of 4.2 is equal to 12 over the sine of 10. So our last cross multiplication step gives us a C value of 5.06. So the first triangle, we use law of sines. The second one, we subtract from 180 to find the measure of angle B.